Today's focus standard comes from Grade 8 Expressions and Equations Standard C, Analyze and Solve Linear Equations. Our topic today comes from simplifying and solving equations, comparing expressions, and recording steps using traditional algebra. And our essential question today is, how do we record the work from the mat using traditional algebra? So this is going to be one of our last ones on comparing expressions, and we're closing in on the end of the unit. So we're starting to take all these steps we've been conceptualizing about how to compare expressions and simplify them, and start to work with it in a more traditional algebraic method. So please take a moment, pausing the video if you need to copy down your header. Be sure to include today's date, sub your question column in your note column, and resume the video when you're ready to begin. So we're going to start out just looking again at the steps to simplify and compare expressions. We know that there are 3 steps. We simplify, balance, and compare. When we simplify, one of the first things we've been looking for is flipping all the tiles from the bottom region to the top. And I've been talking to you about how this is actually a version of the distributed property, and that's why we use the mat to demonstrate how that works and why that works. Then when we're simplifying, we also need to make sure that we combine like terms, which involves removing all 0 pairs, looking for things that cancel out. So that's our first step, is always make sure that both sides of the expression mat get simplified. Then we balance, and that involves looking for identical tiles from each side that can be removed. And finally, with any tiles that remain, we can then compare the values. So what I'd like you to do to begin our problem today is set up a table like I have here. So you're going to need 5 columns, a column for drawing out what it looks like on the expression mat, and then these 3 columns we're gonna take track what's happening on the left side of the expression and the right side, and give an explanation each time. So let's take a look at the problem. So I've gone ahead and set it up here. And so this is our expression mat. I want you to go ahead, take a look at what we have going on here, and see if you can come up with what the left expression is and what the right expression is for each of these mats. So go ahead and pause the video if you need to do that. What I'm looking for here is an expression that would look like this. So on the left-hand side, we have negative 2x minus 3 plus 1. And then in the negative region, so we put this minus sign, we have a negative x and a positive 3. On the right-hand side, we have positive 2 minus 3 minus the quantity x minus 2. So you can see all those tiles here. And what is the first thing we need to do? So we just took a look at those steps. The very first thing that we need to do, and so this is actually not going to talk about any of that, and this is going to say it's our original expressions to compare. So now, though, we know what's our first thing. What do we need to do to simplify this? You said take all these tiles and flip them up. I would agree. So we would actually want to mark that. That's one of the things I've noticed on quizzes and classwork, is I'm not seeing people mark that up. So go ahead and pause the video for a minute to do that. And so once we take all these and we flip them up, the very next thing is what is that mat going to look like? So we copy down everything we had, and then we take these tiles and we flip them up. When we flip them up, remember, we're actually distributing a negative 1 here, and so that's going to change the value. So this negative x becomes a positive x. These 3 positives become 3 negatives. And then over here we keep what we had, and then this positive x becomes a negative. These 2 negatives become 2 positives. So we want to start to record what is actually happening. So we've already given the explanation. We're simplifying by flipping the tiles. This is the distributed property. So what's that going to look like? And it might actually, so this is what we end up with, and this matches what we have on our mat, a negative 2x minus 3 plus 1 plus x minus 3. So why do I notice what I have here is I need to show that I actually have a -1 hiding right here. And what I'm doing is multiplying that -1 times this -x. So -1 times -x gives me this +x, so everything else was already just there. And then if I also take that -1 right here, that -1, and I multiply it by a +3, then I get -3. So I kept the -2x minus 3 plus 1. I kept all of that right here. And then when I distributed the -1 times a -x, I got a +x. When I took a -1 times the +3, I got a -3. So we're going to want to show that same work on the right-hand side. So a similar thing, we keep this 2 minus 3. 2 minus 3 was already there. That was what was in the top region. And then we want to show that we know that this is a -1. And we're multiplying -1 times x to give us a -x. And a -1 times a -2 gave us a +2. So those arrows help us to show that we're multiplying everything inside by this number outside. So here we are. So now we have the traditional moves. This is what I would expect to see if we were just writing it out. And we've explained what we've done. So what comes next? We flipped the tiles. We did the distributive property. What do we do now? If you said look for 0 pairs, I agree. So we're looking for things, and we actually would want to, again, if we're looking at our mat and how do we show that work, we want to show circling things that we know are 0 pairs. So these two right here were a 0 pair. And so we circle things that make pairs, and on the left-hand side there's one more pair that we would circle and show with an arrow, and on the right-hand side we have some. So go ahead, if you haven't done so already, pause the video and mark all those 0 pairs. So as we're showing our work, this is what it would look like everywhere where we can match up 0 pairs. We would circle them and pull them off. And we just copy down what's remaining. So we have a -x, and we have 4 negatives on the left, and on the right we have a -x and a +1. So how do we show our work with traditional algebra moves with what removing 0 pairs are? Well, remember that's just combining like terms. So that's the second part of simplifying. So first is to flip tiles, or really we're looking to use the distributive property to get rid of parentheses, and then we want to continue to simplify by combining like terms, and on the mat it looks like removing 0 pairs and copying down what's left. What is that going to look like though on your paper as we're just writing it out is going to start maybe using that highlighting method. So if we're using yellow for all the x's, and then we include the sign with that, so a -2x plus an x is going to give me what? A -x, right? And then if I combine all of these, so I have -3 plus 1, these are my constant terms. I also have another constant term here of -3. Then I want to combine those, so what's that going to look like? And then I do the same. So go ahead and continue that for the right, and then write down what expressions we get once we simplify by combining like terms for both of these two expressions. So remember, we're still keeping the left separate from the right, and we're combining these things. So a -2x plus an x is going to leave me with a -x, and -1 plus 1 is going to give me -2, minus 3 is going to give me -5, so I end up with -x minus 5. On the right-hand side, this was the only x term I have. I need to keep that negative with it, so -x, and if I combine all these, 2 minus 3 is -1, but if I add 2, I get a +1, so the right-hand side simplifies to -x plus 1. And we're still doing all this to compare. We still don't know, especially having these x variable terms in here. So we still need to work to simplify. So we've already simplified. What's our next move? What's our second step? You said balance, then I would agree. So we want to balance each side, looking to remove identical tiles. And so we want to look to both sides. What do I have? You can look in the expressions too. What do we have that's the same on both sides? Well, we have this negative x that we can remove. So if we do that, we always want to show it. So we want to show that we're balancing by circling the thing that I can get rid of on both sides that is identical, and show arrows pulling those off. So there is one thing that looks a little bit weird about this when we're doing tradition that's going to be different. And so in mathematics, when we're dealing with math sentences, we can't just circle something and say, well, I have something on both sides, so I'm going to get rid of it. We have to find a mathematical way to get rid of it. So mathematically, how do I cancel out a negative x? Because I have a negative x on both sides, and I know that at the same move will cancel it out on both sides. We've talked about how equations and expressions are like a balance, and if what you do to one side you do to the other. So this should look familiar from last year, but we may have forgotten it with but I can actually add an x to both sides, and I would ideally do this so it's lined up, but my computer's not liking that on that left hand side, but here, so we do it so it lines up. So instead of just removing, what we're looking for as we show it in traditional methods is, I do have the same thing on both sides. What can I add to both sides that will zero that out? And I can add an x to both sides, because a negative x plus an x will make 0 and leave me with just the constant term. And same thing on this side, a negative x plus an x will zero out my x term and leave me with just the constant term. So that's how we would show our work using the traditional methods. We know it simplifies to be -5 on the left and 1 on the right. And so we're ready to compare the values. And so you see that I've changed it from a question mark in this middle column to say that -5 is less than 1. And we would, of course, want a final answer of some sort that says how we know this, and so we know that -5 is less than 1, so the right expression is greater. So that's going to conclude our video. Please, you can barely see it probably at the bottom of the screen, but include a summary and study guide questions. Make sure that your notes are complete, and come ready to do more problems in this traditional algebra method in class.